welcome to the Be Unique Online. As already announced, we are launching a series of crash course for subjects Maths and Science. Today will be the first series lecture of Science. I shall be starting with a chemistry chapter, chemical reactions and equations. We already know that 30% of the syllabus is excluded this time for boards, and the excluded syllabus will not be taught in this series. So it will be helpful to you to learn only what is going to come in your board exams. The included syllabus is as shown on the screen. Okay, the first topic or the first introduction of the chapter 1, chemical reactions and equations. We will go in speed, but we will not hurry up. It will be a speed up session, but we won't hurry up. The first introduction of the chapter, chemical reactions, chemical equations. Okay. Before going deep into it, we must know that our surrounding consists of several changes. In our day-to-day life, we come across many changes in our surrounding. All those changes are bifurcated or divided into main two types of changes. The first is physical change and the second type is chemical change. In physical type of change, only the states change. We know there are three states: solid, liquid and gas. So when it is a physical change, only the state means it may convert into liquid from solid, it may convert into gas from liquid, like in ice. We know that the ice cube is solid. When it becomes water, it is liquid. When it becomes vapor, it is gas. So such type of change is known as physical change. So it is a 1-mark question that what is physical change? Physical change is a change where only the states of matter changes. Example, ice. The next part is chemical change. Here the chemistry of the substance changes. During physical change, the water was H2O and it remains H2O whether it is solid, liquid or gas. But when it comes to chemical change, water may change into hydrides, which will change the chemistry of the water. It may combine with calcium and form calcium hydroxide. It may combine with any other elements and form a new element or a new compound. So there is change in chemistry when there is chemical change. So these are the changes occurring in our surrounding. We also see chemical changes in our day-to-day life, like the milk gets spoiled or the fermentation of dough. These are the examples given in the textbook. So this was the introduction to the chapter chemical reactions and equations. Now going into title description. Chemical reaction, chemical equation. There are two words in the title: chemical reaction, chemical equation. Whatever changes are going on, which are chemical changes, those are called chemical reactions. If we want to write down these chemical reactions in our notebook, or we want to write the theory on these chemical reactions, we write it in the form of equations, just like the equations in mathematics, a plus b whole square, etc. Here also we have chemical reactions are written in the form of equations. So the heading says that whatever chemical changes are occurring in our surrounding are known as chemical reactions, and these chemical reactions are written in the form of chemical equations when written in theory. Okay, so now let us try to understand chemical reactions with the example, or chemical equation with the help of an example. Now, as given in your textbook, we will burn a magnesium ribbon in presence of oxygen. So a magnesium ribbon is usually grey in color. This is to be remembered. Magnesium ribbon is usually grey in color. If by using a pair of tongs, I heat it in presence of oxygen, means in atmosphere. We are not providing an atmosphere which does not have oxygen. In atmosphere we have oxygen. So we are heating it in presence of oxygen. So what will happen? The oxygen from the atmosphere will react with the magnesium and it will form a compound magnesium oxide. So initially it was magnesium Mg, then it turned to magnesium oxide in which oxygen was added, which became magnesium oxide later. So this is the chemical reaction occurring. Now if we want to write this chemical reaction in an equation, we have magnesium Mg. Yes, this is the symbol of magnesium. It will react with oxygen. Oxygen is always present in the form of O2, and it will give us magnesium oxide, which is MgO. Yes, magnesium plus oxygen will give us magnesium oxide. When it was theory, we were just saying it, that magnesium reacted with oxygen and it formed magnesium oxide. But when we write it down in the form of equation, we use its symbol. Magnesium is Mg, oxygen is O2, and we form magnesium oxide. This gives magnesium plus oxygen, which will form magnesium oxide. So here, initially it was a separate compound, separate magnesium, separate oxygen, which got converted into a mixture. We can say a compound, not a mixture, a compound which is magnesium oxide. Same way, another example we can study is, if I put acid and iron together, for example, any iron or any metal, say Zn. These are the examples given in the textbook, so I will follow the textbook only. If I put Zn, which is zinc, into HCl, which is hydrochloric acid. If I put zinc granules into HCl, it will form ZnCl plus H2, zinc granules plus HCl, which is hydrochloric acid. It will form ZnCl, zinc chloride plus hydrogen gas will be liberated out. Hydrogen gas will be liberated out. So if we say out the chemical process, the chemical reaction, then we will say that zinc granules reacted with hydrochloric acid to give us zinc chloride and hydrogen gas. But if we want to write it, if we want the theory of it, we will write in the form of symbols and reactions. Zn, zinc, reacts plus, means plus HCl, hydrochloric acid, which gives us ZnCl, means zinc chloride, and hydrogen gas will be liberated. These are the types of chemical changes occurring around us, or chemical reactions occurring around us, and how we write it in the form of chemical equations, the examples which are given in your textbook. Now, one more very important thing to note down is, how will we come to know that chemical reaction is occurring? In physical reaction or in physical change, we can see it, that solid gets converted into liquid, liquid gets converted into gas, etc. But when it is chemical reaction, how will we come to know? So the first point is, there may be change in temperature, very important. Second is, there may be change in color, like here. Initially magnesium was grey in color, while magnesium oxide is white in color. So the change in color, change in temperature, evolution of gas, as we see here. In this reaction, hydrogen gas has evolved. So it is evolution of gas, and there may be change in state as well. So four most important changes to study the chemical change is, there may be change in state, solid, liquid or gas. There may be change in color from grey to white, etc. There may be change in temperature, and the fourth most important, there is evolution of gas. So this is how we can identify whether chemical reaction has occurred or not. Okay, so coming to the next topic, that is chemical equations. We have studied in detail what is chemical reaction and how we write it, that is chemical equation. So now we are going to study in detail about what is chemical equation, how do we write it, what are its components, and how to balance a chemical equation. The most important part of the chapter is how to balance the chemical equation. So first of all, what is a chemical equation? Whatever chemical reaction is occurring around us, we write it down in the form of chemical equation. For example, we know that magnesium reacted with oxygen to give magnesium oxide. This is the chemical reaction occurring. This is the chemical reaction occurring. Magnesium reacting with oxygen to give us magnesium oxide. If we write down like this, then this is the word format of writing a chemical equation. We have written the whole words: magnesium, oxygen, magnesium oxide. As we have written the whole words, it is the long form or word format of writing chemical equation. If I write the same thing in symbols, Mg plus O2 oxygen gives MgO, magnesium oxide. It is unbalanced, but Mg, O2 and MgO, this is the short form or short method, short format to write the chemical reaction, and this is known as chemical reaction. Whatever reaction is occurring, we have written in an equation form. So this becomes our chemical equation of chemical reaction. Now here what is important is to know that magnesium and oxygen are reactants. As they are reacting, they are reactants. This reactants will give us a product. At the end of the chemical reaction, we get a product. So here, magnesium oxide is a product. Magnesium and oxygen are reactants and magnesium oxide is product. The arrow between reactants and products show us the direction of equation. Arrow between the products and reactants show us the direction of equation. Very IMP, very important. It is frequently asked that what does the arrow between reactant and product show? It shows us the direction of the equation, whether it is going from product to reactant or from reactant to product. There are different types of reactions which we will study further, or in further classes you will study. So these things are clear. If we write it in the word format, it is the long form of writing chemical reaction. If we write in short form, in the form of its symbols, it is the short format, and this is also known as chemical equation. These are the reactants, these are the products, and the arrow between it shows the direction. Always reactants and products are put together with a plus sign, also a sign of sum. Like in maths we say that plus means sum. So reactants and products are put together with the help of a plus sign. Here there is only one product, but if there were more than one product, X, Y, etc., then we use a plus sign to know that they are all together. This is the basic of chemical reactions and writing it in the form of equations. Now, the most important part of the unit is balancing a chemical equation. So we will first learn how to balance a chemical equation. Okay. The example given in your textbook is zinc plus sulfuric acid gives us zinc sulfate plus hydrogen. Let me write the short form directly. Zinc plus H2SO4 is sulfuric acid gives us zinc sulfate plus H2, hydrogen gas is liberated. Here we can revise that as hydrogen gas is liberated, it is a chemical reaction. We have already studied it, that how we identify a chemical reaction now. There is only one zinc on the reactant side and one zinc on the product side, means it is balanced. There are two hydrogen in the reactant side and two hydrogen in the product side, means again it is a balanced reaction. There is one sulfur on the reactant, one sulfur in the product, means it is balanced. 4 oxygen in the reactant and 4 oxygen in the product. Here all the atoms on reactant side and product side are equal. When number of atoms on reactant side is equals to number of atoms on product side, the reaction is known as balanced reaction. Very important. If the number of atoms on reactant is equal to the number of atoms on product side, it is known as balanced chemical reaction or equation. Let us take our previous example where we had reacted magnesium plus oxygen to give magnesium oxide. Now look here, only one magnesium means magnesium is balanced. Here we have 2 oxygen, but here we have only 1 oxygen, means the number of atoms on reactant side is not equal to the number of atoms in the product side. That is why this is known as unbalanced, or very important, or skeletal reaction. Unbalanced or skeletal reaction. It is usually asked what is the other name of unbalanced reaction. Another name for unbalanced reaction is skeletal reaction. Now how to balance it? The easiest method for 1 or 2 marks question is hit and trial method. The method given in your textbook is for 4 marks. If they are asking for long answers, then you need to write step by step. That initially there were 1 atom, then we added this, then we removed this, etc. etc. But for 1 and 2 and quick answers, hit and trial method is the best method, in which we will just try to balance both of it. Here there are 2 atoms of oxygen, so let me write 2 over here. I cannot write 2 over here because it is not proper method. I cannot write 2 over here because it will not show the proper chemical compound. So I will write 2 over here, which means that now there are 2 magnesium and 2 oxygen. Now oxygen is balanced. The oxygen is now balanced. 2 oxygen in the product, 2 oxygen in the reactant. Now the magnesium is unbalanced. So we have 2 magnesiums in the product. So I can write 2 over here. 2 Mg, which means now there are 2 magnesium here and 2 magnesium here. And now this is a final balanced reaction. So the balanced reaction is something like this. 2 Mg plus O2 gives us 2 MgO. This is the hit and trial method to balance a chemical equation. Just try it out. Can I put 2 over here? Put and see. If you are getting it balanced, then okay. If not 2, then try with 3. If not 3, try with 4. But for that, you must know that what a compound it is. If it is magnesium oxide, you cannot write MgO2. It is a wrong method. So you need to write 2 MgO. Now again, as magnesium was unbalanced, we tried it to balance by putting 2 in front of it. We cannot write Mg2. It is always written as 2Mg. So these are some basics which you have to be clear so that you can easily balance a chemical equation. The most important part is balancing a chemical equation. Try out the questions given in your textbook, in your exercise. If you have any doubts, you can just comment it out. I will try to solve it as soon as possible. So here we complete till balancing a chemical equation. Yes, so till now we already know the introduction of the chapter. We know the difference between physical changes and chemical changes. We know what is chemical reaction. We know how we write down a chemical equation, and we also know how to balance it by an hit and trial method. Now we are going to study about types of chemical equations or reactions. We have seen various reactions may occur around us, chemical or physical. Specifically, when it is a chemical reaction, there are many types that are seen, out of which in your 70% included syllabus, we have to study only the 3 types. The first is combination reaction, decomposition reaction, and displacement reaction. They are very easy and very much easy to understand and write up. First one, combination reaction. As the word itself says, it is combination of something. Yes, if the reactants are X plus Y, it will give us a product XY. Yes, the reactants are separate, X and Y. It gave us a product together, XY. So we can say that there are 2 reactants. Very important, the definition. When 2 reactants react and give us a single one product, it is known as combination reaction. When 2 reactants combine to give us one single product, it is known as combination reaction. Very easy. An example we have already studied, Mg plus O2 giving us MgO. To balance it, we have put the 2 in front of Mg and MgO. Yes, very easy. There were 2 reactants here which gave us only one single product. So 2 reactants reacting together to give one single product is known as combination reaction. Very easy, no doubts. Now if we apply heat, this triangle is a symbol of heat. To combine these both reactants, it is known as thermal combination reaction, as we are giving heat. It is also known as endothermic combination reaction. If we give heat to the reactants to combine, it is known as endothermic, means giving heat. Thermic means heat, endo means giving. Endothermic combination reaction. Is that clear till here? Combination reaction. The second one is decomposition reaction. It is opposite to combination reaction. The word decompose means to break down. So, combination reaction is opposite to decomposition reaction. Here, there is a single reactant, a complex single reactant giving us 2 products. Yes, only one reactant which will be complex, a bigger reactant, giving us 2 products. So, one reactant decomposing to give 2 products is known as decomposition reaction. Here also, if we apply heat, it is thermal decomposition reaction. If we do it in presence of sunlight, it is known as photo decomposition reaction, because from sunlight we get the energy of photon. So it is photo decomposition reaction. Example is, it is already given that AgBr, silver bromide, in presence of sunlight gives Ag plus Br. Means it was AgBr initially, a complex reactant was present. In presence of sunlight, it gave us silver and bromide, two different products. So one reactant giving two products is decomposition reaction. Two reactants giving one product is combination reaction. So I hope it is very clear and it is very easy. The question is frequently asked that give difference between combination and decomposition reaction. They will ask the definition of any one and tell us to give the difference of both. So there are types like thermal decomposition, photo decomposition. There is one more which is electrodecomposition. If it occurs in presence of electricity, it is known as electrodecomposition. So I hope it is clear for both combination and decomposition reaction. Now the last one is displacement reaction. The word displacement itself suggests that it is something displacing, replacing, something like that. The example given in the textbook is iron Fe plus copper sulfate gives copper plus iron sulfate FeSO4. The iron is alone initially in the reactants. It reacts with CuSO4, copper sulfate, which gives us Cu, which is alone here, and FeSO4 has formed a compound. We can clearly see that iron has displaced copper in copper sulfate. As only one atom is displaced or replaced, it is known as displacement reaction. Not a big deal, only simple displacement. One atom will take place of another atom. This is known as displacement reaction. So in this syllabus, in our 70% syllabus, we have to study only these three types of reactions: combination, decomposition and displacement reaction. There are also double displacement, reduction and oxidation and applications of oxidation reaction which we do not have to study in our syllabus. One important question usually asked for 2 to 3 marks is respiration is known as decomposition. Respiration is known as decomposition reaction. Why? Explain. It is usually asked that it is a part of decomposition reaction. So hear it very properly. Respiration, we will study in biology chapter 6, we will study in detail. But respiration is intake of energy from the food we eat. Respiration is not taking carbon dioxide or taking oxygen and removing carbon dioxide in plants and animals. It is using the food we eat to get the energy. So, during that process, whatever food we are eating, which is carbohydrate, will decompose. It will get separated into smaller elements, smaller group of atoms, and at last it will give us energy in the form of ATP. Energy in the form of ATP. So one complex molecule we had eaten, that was glucose or carbon dioxide or carbohydrate containing elements or compounds that we have eaten, it will get decomposed. It will break down into many simple compounds, and at last it will give us energy in the form of ATP. And this whole reaction is known as respiration reaction. So we can say that respiration reaction is a decomposition reaction. So here we have totally covered all the concepts of chapter 1 in our crash course batch. We complete chapter 1 over here. I hope you enjoyed the video. I hope you liked the method of teaching. It was speed up lecture, but we have not hurry up. We have just speed up. We have understood each and every topic clearly. If you have not subscribed the channel, please go and subscribe the channel. Please like and share with all your friends so
much.